This week, Santiago Torres, alias assistant professor at Purdue University, discusses how everything's valid in code and war, attacks on the software supply chain. In the security news, AI on your Pi, no flipper for you, stealing Teslas by accident, firmware at scale, the future of the Linux desktop, protect your attributes, SOX 5 for your burp, TPM 2.0 vulnerabilities, the world's most vulnerable door device, and hiding from, air quotes, real hackers, sandwiches, robot lawyers, poisonous EpiPens, and profanity in your code. All that and more on this episode of Paul's Security Weekly. This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly.
Oh, hey, welcome to the show. Yeah, hey, let me introduce you to a man that just found out which days of the week were the strongest. Saturday and Sunday. The rest are just weekdays. Mr. Paul Asadorian.
Welcome, everyone, to Paul's Security Weekly. It's episode number 776, being recorded on March 15th, 2023, right here in G-Unit Studios in Rhode Island. To my left, Mr. Larry Pesce.
Hey, how's it going?
Good to have you, man.
Yeah, we missed you last week.
Yeah, I missed doing the show.
I wouldn't expect to say we missed you. We missed you last week.
Larry and I did a review. We should have recorded it. I think we might, I don't know, we might talk about doing that, but Early Times Kentucky whiskey comes in this beautifully packaged plastic bottle. We said it had notes of
floral notes of
pine sol
and athlete's foot.
Yes.
Is that fish on it?
Yes,
I mean, does it have aftertaste of fish?
Freshwater fish. So you got bass, rainbow trout, let's see, pike, sunfish, bluegill.
And surprisingly, no aftertaste of fish. It had an aftertaste of pine sol and sour feet. Yep,
yes,
athlete's foot. Yep.
Feet. Yes. Miss Mandy Logan is here with us. Mandy, welcome.
Good evening. So somebody gave me a gift the other day randomly of green apple Smirnoff, and I'm not sure if I should be insulted. I just don't know.
It also came in a plastic bottle. So I mean,
it's a plastic bottle.
All fine spirits come in plastic bottles, just like all fine wine comes in a box. Mr. Sam Bound is here with us. Sam, welcome.
Good evening. You know, I'm thinking that making whiskey out of fish might be more environmentally sustainable. The only thing cooler would be to make it out of algae.
That's Mr. Tyler Robinson is here. Tyler, it's good to see you, man.
Good to see you too, buddy.
Well,
How you been?
You've been busy. We haven't like hung out like virtually or not. It's very sad. It's nice to have you on the show though.
Yeah, bad guys don't stop, so it's been busy.
Sorry, I keep reading Tyler's shirt.
Be a part of the 2023 SC Awards. The prestigious and competitive SC Awards program recognizes outstanding innovations, organizations, and leaders that are advancing the practice of information security. This year, there are awards in 36 categories up for grabs, including Best IT Security-Related Training Program, Inventor of the Year, Best SASE Product, and more. Visit securityweekly.com/SC Awards to submit your entries by March 13th, which only applies to those that have time machines. Santiago, that's right. Santiago is an assistant professor at Purdue's Electrical and Computer Engineering Department. His interests include binary analysis, cryptography, distributed systems, and security-oriented software engineering. His current research focuses on securing the software development lifecycle, cloud security, and update systems. Santiago is also a member of the Arch Linux security team and has contributed patches to open source projects on various degrees of scale, a maintainer for the update framework, and lead in the InToto and SigStore projects. Santiago, welcome to the show.
Hello, it's my pleasure to be here.
Thank you for joining us this evening. Santiago, how did you get your start in information security?
I mean, it's been quite a while, but I think I actually started with physical security first. I was kind of into lock picking and this sort of a capability of opening devices and understanding them and being able to change them. And so I started doing software. I realized that this sort of a compulsion transfers between physical and virtual.
Nice. And what got you interested in the kind of supply chain aspect of security?
Well, when I was starting my graduate studies, I was already into information security. I was trying to do very high level crypto, very theoretical stuff. But I ran into who eventually became my PhD advisor, who was working on a project called Tough. And I was mystified because the idea behind Tough was just, well, how to get an update from a system securely. And I thought, well, it's 2010. Somebody must have figured this one out. And after looking into the weeds and reading the papers and whatnot, I started realizing that it's really not that easy, and it's also a very, very good way to attack people. If you look at some of the OG large scale software supply chain attacks, the one that attacked software update systems, you have things like Flame, the malware that by now it's in the history books. You have things that nation states are able to use to essentially control a whole population or a whole country. And that's when I realized that, well, first of all, it's not an easy problem to solve, and second of all, it can really cause a lot of devastating damage. Of course, this was before SolarWinds and Log4j and all of that. So I was, I was almost ready for this to happen.
You were excited when that happened, huh?
It was somewhat of a told you moment.
Yeah,
but,
yeah. Well,
yeah,
it's interesting too.
good.
Like, I mean, in order to gain control of a aspect of a supply chain, right? That could be part of some aspect of a supply chain. You do have to use likely exploits of some kind, right? Like the initial access. Once you get that, though, you leveraging that to gain access to other systems, as I think you've already said, Santiago, is like a very elegant and almost easier way to do that rather than breaking in all the systems individually. And that's really one of the things that makes it a target for attackers, right?
Definitely. I think that's what makes it so interesting, that it requires you to understand the fundamentals of cybersecurity and even advanced cybersecurity that goes from secure boot all the way to applied crypto, but also apply it in somewhat of a socio-technical fabric, right? You need to think about if somebody hacks into this part of the supply chain, they may be able to get away with something that's way more devastating than just breaking some, bootloader on a certain machine or something like that. And that's kind of what makes it so much fun, to be quite honest.
Yeah, absolutely. And it's interesting too. Your involvement in Linux is kind of what sparked my whole interest in all these segments that we've done on supply chain. Is how do you protect the Linux user? Right. I don't want to just pin it to Linux desktop users. Like all three of us are very aware of this problem. But not just Linux desktop, but Linux servers. How do I get software down on my systems securely? Right. And that was some of the first times I started looking at Linux and started doing package updates. I'm like, cool, is software coming from somewhere? How do we protect it and protect our users in this ecosystem?
Right. So, it's funny you mentioned Linux, because I was just watching The Last of Us, the HBO series, last weekend. I just binged it all. And this virus that takes over the planet and just pretty much causes civilization fallout, it's on the wheat, on every single thing that's eaten. And that's the way I see Linux. It's such a fundamental part of the internet, of the cyber world, that if you are able to break into something that's fundamental as the Linux kernel, then you pretty much have the keys to the kingdom. And well, yeah, that's the place that we need to spend a lot of our efforts.
And wasn't there? So we talked about the Galen Urso bug, right? the Death Star plans, where he purposely put that vulnerability in there. That was like the big realization for me when I watched Rogue One. I'm like, that was put there on purpose. I'm like, what are the examples of that happening in software? And I think you, Santiago, pointed out there was a research paper that was retracted where, was it graduate students did that? They introduced vulnerabilities through pull requests in the Linux kernel?
Yeah, so that was actually something that I got to exercise or like experience from both the academic and the open source world. Part of my research is again on this software supply chain attacks, but I try to build systems. So I don't effectively try to hack on systems. I try to understand how systems can be hacked. And there was this paper from University of Minnesota, I think it was, that they were trying to essentially do this sort of attack. They called it the hypocrite commit attack. You're essentially being two-faced about the whole open source software contribution. And when I heard about it, I was like, "Wow, this is amazing! I got to read this paper even before it comes out." And then I asked around in the Linux kernel IRC channels, and they were like, "They did what?" And then suddenly I realized that this had been happening. Push comes to shove, a couple of months pass, and no harm done, really. But it really does highlight how even a researcher could attempt to do something like this. What I think was more scary on this aspect is that I don't think we understand the supply chain, especially for the Linux kernel as it is. Even if you ask for Linux kernel developers themselves, they don't know who's doing what, right? An example that from a colleague at the Arch Linux security team, Morten Linderud, he was mentioning that, for example, Debian and Ubuntu, they pull patches out of the version control of the Linux kernel without looking at it. They called it automatic backports. The consequence of this is that maybe they put the hypocrite commit and nobody knows if it was done, and then there's really not an easy way to check if this happened. So all in all, big mess.
But these researchers from the University of Minnesota, I read their paper and their retraction, which is like, I mean, a rabbit hole, because their retraction includes the email correspondence that they had with the Linux kernel team. And it gets kind of, there's a lot of friction there, of course. But the whole reason they had to retract it was not because it was successful or not successful. They just failed to get permission to do this. Is that an accurate assessment?
That's pretty much within the ballpark. Without getting too lost into the bureaucracy, essentially what happens is they needed to get permission from the university as well. Any sort of research that requires human subjects needs to go through a part of the university called an institutional review board. They take a look at all of this sort of protocols, and they try to assess the damage and minimize harm and all these sort of nice things that you want to do with modern research. To my understanding, they didn't do that, and they didn't even tell the Linux kernel developers. Yeah. So, yeah, it was pretty much in violation of a couple of things. I think it's unfortunate because at the end of the day, every single practitioner that I asked, like, "Hey, do you think this could happen?" They go like, "Yeah, of course. Somebody could just underhandedly put a patch that has a vulnerability on it. Why wouldn't you be able to do that, right?" So yeah, it's almost unfair to the researchers to not be able to show it, but it's also unfair to the open source community to do it in such a way.
Now, one could play devil's advocate and go, there's so many vulnerabilities that exist already that we don't need to introduce new ones.
Yeah, there's actually very interesting research from this academic at NYU, Brendan Dolan-Gavitt. He actually came up with this system to introduce more vulnerabilities that were harder to exploit or easier to exploit, but not as damaging, just to make hackers more, I guess, confused. So I don't know. Everything is valid, right?
Right. Yeah. What do the Linux kernel developers, and I know you're involved with some of this with Arch Linux as well, how do you validate all of these patches and pull requests coming in? Because it seemed to me that the University of Minnesota case, that at least a couple of the kernel developers were like, no, that's not flying, right?
Yeah, I mean that was also funny because during the fallout of this whole thing, it took the so imagine, I don't know, you run into somebody and they tell you like, hey, I don't know, your windshield is broken in your car, and you go like, I don't think it's broken, but you start trying to check a little bit more carefully, right? So when all of this thing came down, a lot of kernel developers were like looking at these patches and they were like, I don't think there's anything wrong with them. So a bunch of them were actually not really vulnerable.
Yeah.
The researchers failed to actually introduce these vulnerabilities.
But it's interesting that some of them were rejected because not because it was a vulnerability, but they were just rejected because of like other reasons. So I mean that breeds some faith for me, especially in the Linux kernel, which I think is doing a really good job of protecting that basically critical asset for the internet as a whole and computing as a whole, right?
For sure, yeah. I think if there's a golden standard on this, it's the Linux kernel. But that's the thing, right? People are not trying to do this to the Linux kernel. If I had to guess, they would try to do it on some random, I don't know, TIFF processing library that nobody's using it, or something that manages like, I don't know, Windows media files or things that you just really don't look at, but they're included by every single browser, and they have very weak sandboxing at times, and everybody transcodes weird file formats automatically. So that's what I'm scared about. Not exactly the Linux kernel.
Santiago, tell me about the project, the update framework. You mentioned it earlier as one of the first, I think, projects you were involved in the software supply chain, correct?
Yeah. So the update framework is a system to. Let me actually start with the tagline. I think that's very evocative. It essentially is the S in HTTPS, but for update systems. The idea is that you can add this overlay on your update stack, and it manages all of the security aspects of your update system. Historically, this project started by looking at how can a nation-state attacker try to modify the way that an update system works to compromise pretty much anybody that's updating a system, right? Again, think about the scale, right? There was this example. I have this collection of open source supply chain compromises that I look at. There's this example of I think it was North Korea replaced a PHP package on the South Korean mirror, which again, it's why would they do that, right? So the update framework tries to take a look at it from that perspective, and it adds a lot of security properties that a lot of update systems really do not have. It's actually, historically, it came also from cooperation with the people at the Tor project to update the Tor browser. Part of a challenge there is a lot of the people that are using the Tor browser are activists in, I don't know, oppressive regimes and, I don't know, in the middle of a war zone and things like that. So you want to really step up the game and make sure that people that are trying to target that like last mile aren't able to fully compromise the system, that you can recover from a compromise, that you don't lose the root of trust if, I don't know, a hash algorithm is broken and things like that.
So in those cases, do you see from both a real world and kind of an academic standpoint the big push for the SBOM? SBOM makes a lot of sense. There's a lot of things that it's going to provide, but again, I think we're seeing this as kind of the silver lining panacea that everybody's after. And in those cases where you're talking about a supply chain attack and maybe not able to detect or see those tainted packages, do you see the SBOM being able to help, or is that kind of an after-action remediation step?
I think it has a couple of problems, but again, I will preface everything that I'm going to say with I love SBOMs, and I think the community is working behind it. I worked for a little while with the SPDX people. And they're like doing a fantastic job. I think part of a problem is, and without getting too academic, I think there's an abstraction, which is the software supply chain, and then there's what really is the software supply chain. And it's not necessarily a supply chain, but it helps us understand how things are working. The reason why I'm telling you this is because software supply chain compromises in general have different shapes. And I don't think there's a solution that fits everything. If anything, if I had to make a prediction, I think there's going to be a large-scale open source software like supply chain attack. There's going to be an SBOM involved, and we're going to look at it and go like, oh yeah, of course, we need to add more stuff to the SBOM. I think we need to look at it from the opposite perspective, and we need to start trying to predict how these things are going to start shaping up, and maybe come up with other solutions that work alongside like the SBOM ecosystem in a sense. But take a look at the things that are coming, right?
I want to talk about Linux for a moment, because this thing that sparked this whole thing, and it's interesting how this debate and kind of ongoing projects are still talking about this issue of how do I get software to a Linux system, right? We use this as an example. I think it applies to other operating systems, but Linux being free and open, it breeds a lot more of the software distribution mechanisms such as apt and apt repositories. Then you've got Flatpak, you've got Snap, you've got Arch Linux that has its own packaging mechanism. Am I missing one? App images are another. I mean, you could always compile from source, but like, who wants to go through that headache anymore? I mean, unless you use Gentoo, you do.
And they do that every day.
And they do that every day. But given all of these mechanisms, I think kind of like usability, stability aside, my primary concern with all of these is security. Like, how can I trust... In Santiago, it's not so much I don't trust who wrote the code, because I got a higher degree because you are involved with the other project, SigStore, right? So that breeds confidence that whoever wrote this code, it's good. But I'm worried about who packaged and distributes it in that supply chain. And when I take all this software down on a Linux system, how do I know it hasn't been tampered with at that kind of last leg, last mile?
So it's funny that you mention it, because I think it's almost unfair to packagers, because a problem with supply chains is that any step in the chain, it's game over, right?
Mm-hmm.
They could hack some FTP mirror that, I don't know. From packaging software, I've seen things like, every time PyOpenCL is updated and it's tagged on the GitHub repo, the maintainer forgets to sign the tag.
Mm.
They're getting better, but every time I need to send them an email going like, hey, by the way, I cannot verify the signature on your thing because there's no signature. And well, it's almost like every single step is game over, right? It takes one mistake and everybody gets hacked. That's also partly why I think we need to develop better systems to provide better traceability all throughout the chain.
Well, what do you think of a solution like ISO 27000, which is supposed to secure the whole chain for making military products?
So I think in general, that's when I think the abstraction for supply chains breaks down a little bit. I think what we have in software is that it is not that anybody walks into into the software mines every morning and they start like mining software, and then they come up with like software ores, and then they move it to through a supply chain, and there's like chains of custody, and people sign off the handover and things like that. Although I have a system that tries to do that, it is a little bit more immediate and it's way more automated. And I think something like a third-party certification, like ISO, taking a look at your processes and telling you that they're right or wrong, is applicable to a certain extent. But I think we also need to think about the way that this sort of like immediate software development happens, right? We think about CI/CD and like pretty much push to deploy in less than 5 seconds as something that also changes and reconfigures itself every day, right?
Yeah, but it just seems to me like your supply chain is the same as a manufacturing supply chain, and you could have a special secure version of Linux that meets some compliance standard, and then you'd have some higher belief that every step has been audited and make sure that it's all using proper cryptographic protections and so on.
That's things that we run into. For example, FIPS compliant in a bunch of like HSMs exists, right? And part of what they're trying to look at is, well, did you implement the algorithms? Are they implemented correctly? Do you follow export laws? Things of that nature. I agree, but I think for maybe very highly critical processes or projects, you may be able to achieve it, and when you have like a very low turnaround time, I do think that things similar to the cloud, it may be way harder. I think if anything, we need to develop the same types of techniques, but in ways that they apply to the way that we develop software. Does this make sense?
Well, in a private company like Microsoft, you don't have this same issue, right? Because all the developers are in the company and they're being supervised and audited and such, right?
Yeah. So I'll let you take that one.
But there was a great story. Well, it was a bad story for Microsoft, but it was a great story where they had a contractor that had a certain level of access to the code behind the Microsoft Store, and they provided a mechanism for developers to be able to test their code and perform transactions all the way up to the point where, like, the transaction would go through, but there was just no credit card that was processed on the back end for testing. This developer figured out that he could buy gift cards, but the gift card was still emailed to him, even though he didn't pay for it, because that mechanism was broken. And through a couple of bugs, turns out he had a pretty nice side business to the tune of millions of dollars at one point that he was selling. I mean, because it's 100% profit, he's selling the gift cards. And the only reason I truly believe, if you listen to the story, that he got caught was like all great criminals get too greedy. And he was doing it at scale. And it was at scale that all of a sudden Microsoft started noticing that was happening. I firmly believe had that kind of flown under the radar and kept it small, that would have gone on for a long time.
Well,
yeah,
but I mean,
there's also another example from Microsoft where they pushed an update that actually bricked a lot of computers. It actually bricked the computers. And for a while, they weren't fully able to understand what happened. And it turns out that it was an internal beta release that somebody needed to sign off, and they signed off by mistake or something, and then it went off the races. Everybody in that patch Tuesday, I guess, I don't think it was even released on a patch Tuesday. The few people that actually update in time have their motherboards essentially blown away.
Yeah, and I think Black Lotus is a great example too, where we look at the supply chain of the entire boot process, right? And we do our due diligence and we enable secure boot. Although I have data that shows that not everyone enables secure boot. That's a different topic, right? But let's say you are enabling secure boot, and the attacker in this case, what gets me is they're able to bring their own vulnerable bootloader. And since Microsoft has not issued updated the revocation list for these bootloaders, plural, it basically gives us a forever day. That is a nice kind of supply chain style attack. How do we combat this problem? I'm going to convince Microsoft to push a revocation list, which I think helps.
can you add some kind of third-party revocation list, like antivirus at that level or something?
Well, see, that kind of breaks the whole principle of the root of trust, right? No, you can't just extend roots of trust to other people, because then it's like a tree of trust at that point. It's not as trustworthy. I had the same.
There's some OEMs overlay some of that, right, where they're building a custom BIOS or BIOS loader that is leveraging what they consider secure, but that's usually further down the stream and not further up the stream. I think that would be a good place if anybody was going to do it, that they could do it.
Well, didn't that happen with Lenovo and Superfish?
Yes.
They essentially injected a backdoor in all of their laptops.
Yep. That was exactly what I was thinking, the exact opposite way. That's a bad thing in some cases.
Yeah.
Could you just block all kernel modules, not let any new ones be added? How often do you have to add one anyway?
You'd be surprised.
Yeah, I was going to say, that's actually pretty active. You probably could for like very
on the server
static systems. Yeah. Yep.
On the server, I find a lot of times on the server side, Tyler, that they'll you can get to a point where you're replacing your own platform key and key exchange key and just owning that whole root of trust because you're like, this is not going to change. It's totally static, right? So you're just basically taking over the secure boot supply chain and the boot supply chain at that point.
I think some of those kernel modules, though, like even there are certain kernel modules that hook driver functionality, and you end up with some weird dependency issues with some of the way that drivers load and a driver update or a hardware, call it an IC2 flash or something like that, that then affects the driver and the driver fails. Then you end up with a bigger problem. I think that's usually the reason why most people don't mess at that level, is because of the chain reaction that's unintended.
Yeah, and Santiago, you've looked into some of this stuff. I think you were telling me earlier that you really like the kind of picking on the firmware supply chain because it's easy pickings.
Yeah, well, there's another academic at Harvard. It says IoT and embedded. It's almost like we forgot about the last 20 years of software compromises, and we're starting to come up with everything together. But it's interesting because when you think about, I don't know if you know how the firmware on your machine updates if it's a Linux machine.
The answer is it depends. If they've put it in LVFS, it can update that way. However, it depends on which firmware you're updating. So I've looked into this quite a bit actually. In order to update something like an Intel ME, I'd have to boot on Windows and use the OEM supplied tools to update it. So you bring up a very good point. For Linux users, it can be super hard.
It is super tricky, and as you say, there's a lot of ways, and a lot of the times it's for example, the BIOS of your machine. It probably went through a software supply chain in and by itself, because there was the motherboard manufacturer took some code from probably a recommendation from the chipset manufacturer, and then they essentially repackaged everything together and made it work for their
from multiple chipset, right? They take code from like reference code. I actually just talked to the person at Intel who's done this for a long time, and they take reference code from Intel, but they all go through. You're exactly right, Santiago. They all go through a different path of customization because of other hardware, other dependencies. Yep.
Yeah, it is crazy when you look at the motherboard in the machine that I'm right now. It has a full-fledged USB stack at the BIOS level, and you can fuss that. And I'm sure there's some very, very nasty stuff in there. So I don't even like at that like single point level. I'm sure there's something scary in there. And then to think about software supply chain compromises, then I can only imagine how bad it can really get. And as you said, some of these like firmware low level cases are very, very hard to fix. I don't know if you recall I think it was in the Nintendo Switch that there was like a route through the USB port that was essentially unfixable because you couldn't get a fix to that part of the flash.
Yeah, I definitely, I don't remember that one specifically, but it's kind of scary to think that sometimes even the OEM, the manufacturer, can't fix things. I mean, oftentimes they can. Like with UEFI, yes, I mean, with hardware limitations in place that are the ultimate kind of guardrails, everything else in between they conceivably could fix, provided the hardware they have supports it. You can't fix that as a user a lot of times because like there has to be multiple points in the code. So like you can't just go like make a configuration change because there has to be code like an SMM that checks that, SMRAM that checks that, right? So it has to be an SMI handler that goes and checks for that certain thing. If that's not in the code, you can't update it yourself. You got to get it from the OEM. But you're right. There's also like hardware limitations. Like that part of the hardware just doesn't. We didn't order the chip that had that feature, so we can't fix it, which is scary.
It's scary. Some of the research that we do in my lab is we buy IoT devices. We try to desolder the flash, and then we try to dump the flash. And it's funny how you can actually find, I don't know, a Linux kernel version 3 point something with a bunch of CVEs on it, and I don't know, and netcat process listening in, just like blindly piping stuff into a file for some reason. I don't know. I think that particular space gets a little bit scary just because it hasn't been as exposed as other systems like the cloud. Everybody's been hitting the cloud for the last decade, but I don't know. Home IoT devices or even routers are actually just catching up with this sort of a trend in software supply chain attacks.
Are they even catching up?
Do you think they'll ever actually catch up to that, though, given the consumerism and consumers wanting a product with the maximum amount of features for the lowest possible price, and profits from a capitalist side trying to make as much money and sell as many products with a short lifespan to make more money because they sell more products? So can we actually solve that from a vulnerability and a software supply chain risk issue unless we put an expiration on things from a consumer side? And then you end up with a whole nother problem that consumers come against with right to fix and right to repair stuff.
I think that's a great question. I think it boils down to the SBOM problem, but also all of the other things that we actually need to think at a supply chain level. To give you an example, you buy a bottle of pills, right? An SBOM or a BOM would essentially be the list of things that it has, right? It says it has this ingredients, it has this it has this active ingredients. It may also say things like, oh, it was manufactured in a factory that was also manufacturing this other chemical. So if you have allergies, be careful with that. But we also need to think about aspects like, does this have an FDA approval seal? Does this have an ISO certification because it's a high assurance device? And that should also be somewhat of a requirement, especially when you're acquiring a piece of IoT. It should have other things like, is there any sort of information that I don't need to ship to the consumer for them to verify manually, but something that I need to give to a government regulator so that they can make determinations whether this is fit for consumption or not. And I think that's all the sort of stories that we need to start supporting, not necessarily within an SBOM, but within essentially a software supply chain ecosystem.
Santiago, in Toto claims to be a framework to secure the integrity of the software supply chains. That's a project you're involved in?
Yep, that's a project that I started doing my PhD. The way to picture it is, imagine that every single time you did something with software that changed or gave any sort of a determination about software, like either you look at it and you say it's good or bad, or either you take something like source code and you build a binary, you create a little certification saying that you did what you did. It's a little bit similar to SBOMs, that once you have enough certifications, you can actually take a look at the software and say, well, do I trust this? It's a little bit more expressive than SBOMs in that you can actually say, well, what tools did you use to make an SBOM? When did you generate the SBOM? Based on what information did you generate the SBOM? You can attach other things like SALSA, the security levels for software artifacts. It's actually by default wrapped in an Toto wrapper. You can, for example, do a vulnerability scan, spit out the results, sign that, and then attach it to the software artifact. And the goal of that is to essentially provide this sort of like high-level visibility. What is going on? Who did what? And what do they say?
Yeah, that's awesome, because I think it solves some of my SBOM kind of concerns, where you've just got this JSON blob that says, yes, this is what makes up the software, and like maybe we sign it, maybe we don't. But what was your process for signing it, and how do I know when it changes and if that change was authorized? Right.
So it's funny you mentioned I'm actually running the same SBOM tool, well, a different SBOM tool on the same thing. I take the top 5 SBOM tools. I run them on the same thing. And then I try to look at whether they come to the same conclusion, and it's unsurprising that they don't. The metaphor that I'd like to think of is, instead of thinking of the of the ingredients we use to make something, to make the SBOM and produce the SBOM as we're making the something, which is how it happens in the physical supply chain. Right now, we just build the thing, and then we give it to a tool, and we say, hey, figure out what I did, and then spit out something like an SBOM, so I essentially comply with I don't know, executive order or whatever. Which I think that's again missing the point. We need these SBOM things, and they need to be accurate, and we need to rethink the processes that we're carrying out, so that the information in the SBOM is actually trustworthy.
Yeah, agreed. It's a way to separate the good from the bad of the ingredients. I mean, that's part. I mean, having the ingredients is one thing. Knowing if the ingredients are really are what they say they are is another level of validation. It sounds like Intoto's more kind of in tune with.
Yeah, I don't see them as competing though. I think you can use both, and I do see a world in the near future in which you can use Intoto to sign SBOMs, Intoto to provide more context about an SBOM, and these two techniques together, then you can determine whether you really trust the SBOM or somebody's just trying to, I don't know, slap a label on something and then go on with their day.
Right. Tell us, we've talked a little bit about SigStore, and I'm still not 100% clear how it works and I understand how it helps. I understand like the goal that it's basically an easy way, easy in air quotes maybe, way for developers to sign their code and say, yes, this is the code. I was the developer and this was my code. Is that accurate?
Yeah. So SigStore actually ties everything together very nicely in that it's a way to discover software signatures in a transparency log, and also generate one single-use signatures for something without actually having to manage the keys. The way that it works is you essentially generate your public-private keys for one use, and then you convince an identity provider that you are who you claim to be.
Yep.
It can be GitHub, it can be Google. What this identity provider will give you is essentially a token that then you can exchange at SigStore to get your very short-lived certificate. It lives for 30 minutes. I think it's the window that's configured right now. So then you sign something and then you stick it on the transparency log. Now you know when the signature was made. You can get rid of the cryptographic material. You don't need to keep the private key anymore.
Mm-hmm.
And then verifiers can verify the signature based on your identity. You can say, well, this is this developer from GitHub. It's signing a Git tag, and they signed it at this point in time using their identity.
That's really amazing, because there's a lot under the covers there to make that happen in an automated fashion, right? It's a great service for developers that, like you said, don't, because we would just screw it up. Like if I were trying to say, I would guarantee the first time I would screw it up. I'm trying to do all that myself.
It is amazing. And it's of course the work of dozens, if not hundreds of people working tirelessly in this. This is the beauty of open source. But you see it, that there's companies actually adopting this as part of their security strategy, because as you say, one of the biggest pain points that we have is managing these things, right? Somebody loses a private key, it gets, I don't know. I think Windows Driver had that issue, right? Somebody stole a signing certificate for a large.
Oh yeah, I know people that collect those.
So yeah, you don't want to be losing these things, right?
Yes, that would be bad. Tell me a little bit. Go ahead, Mandy.
I would say back on SigStore. So Santiago, my understanding is that even though there's kind of 6 main parts to it, they can each be used individually if they don't want to use the entire suite of what comprises SigStore.
Yes.
And
there's essentially 2 components. There's Recore, which is the signature transparency log. In theory, you're allowed to.
Yeah. Will you talk more about Recore? Because that's the part that I was most interested in, and also wanted to know why using it, like what are situations where it would be used standalone?
So for example, you could deploy Recore locally inside of your company as just a signature transparency log for software. Spoilers, you can actually submit Intoto attestations to it. It supports Intoto natively. So what you can do is you can say, every developer in my company will be signing every single operation they do into the log, and I will use my own root of trust, and I will issue them keys if that's what you desire. To give you an example, Datadog uses in Toto. And what they do is they hand each of their developers an HSM, a little YubiKey that they use to sign things. So you can do things like that in which you manage the root of trust yourself. You can deploy the signature transparency log internally, and you can use that to provide very highly granular operational and cryptographically signed provenance information for your software development lifecycle.
Okay, and just for the listeners, the Recore, the synopsis of it is a built-in transparency and timestamping service that records signed metadata to a ledger that can be searched but can't be tampered with. And that's just one of the 6 parts of SigStore.
Yeah,
Wait, so
I think that's
you mean like blockchain?
it is. So the way that I describe to my students the blockchain or a transparency log is, in a blockchain you need to ask for permission to write, and then you spend a lot of time asking for permission. And in a transparency log you ask for forgiveness for what you wrote. But very similar, yeah.
Santiago, this is very self-serving for me, as I use Manjaro as my Linux desktop. I'm obligated as a Linux desktop user to tell you that I use Linux and which distribution it's in that unwritten.
It's kind of like CrossFit, right?
Yes, CrossFit, vegan. I'll have to disclose that. Tell us about the Arch Linux security team. I want to know a little bit about the packaging mechanism specifically, because what I've discovered is it's unique. It's not compiling everything from source in Gentoo, but it's not a .deb format or the Red Hat variant, right? It's RPM. It's somewhere like in between. Is that a fair assessment?
Yeah, I would say it's fair. The philosophy behind it is you have the sort of pre-built binary experience, but it's also very friendly to almost the Gentoo experience if that's what you want to do. The goal is for you to be able to control the system to a way more granularity than, say, a Debian or an Ubuntu or an RPM. The build scripts are very exposed to users, and there's the AUR, of course, that then you can use to build your own stuff.
That's the Arch user repository. That's different from
Exactly.
the official repository, which now I love because I can find pretty much any piece of software. Like, I don't think I've really found a piece of software that I needed that wasn't in the official Arch repositories, or especially in the user one, which is amazing.
It is pretty cool. I used to be a Debian guy myself, and I don't know. I installed an NVIDIA driver and I killed my computer for like the 6th time.
That should be a t-shirt. I think if you're a Linux desktop, you should I installed an NVIDIA driver and killed my system is like a badge of honor.
and that sounds like Debian, right?
That's any version of Linux. Okay, let's just put that out there.
I mean, and back then I just didn't understand what happened. I was like, I thought some smart people were behind this whole thing, but it's just like nobody knows. Like, somebody writes some shell script, it spits a binary, then some tries to guess some X11 config, and then you try to put X11, and of course it's not the version that they wrote the shell script for, and then it's all a mess. In Arch Linux, the NVIDIA drivers are way better. They're actually tied to the kernel version, so there's a lot more due diligence there. And then that's why I switched. I
like the control though, and I think this speaks to a security thing too. I can control which Linux kernel version I'm on, and stuff is tied to that, and I have control over that, and I think that allows me to better control the security of my system as well. As the Linux kernel advances, I get better security, and I feel like there's a tipping point. Once you kind of push that kernel version a little too far, you start running into stability issues, and you can back it out and go back and be in a safe place.
Yeah, that's the thing. I think it does have a learning curve that you go like, why am I like having issues with, I don't know, Chromium beta not being detected by Netflix, which happened to me. It happened. I thought it was so new that I thought it was old.
Yeah, but the thing with that is the reason why I use Manjaro in its Arch, it's essentially Arch Linux with a little more testing, right, and some training wheels, right? But under the covers, it has the same package managers. But I find that if I had a problem previously, like an Ubuntu or Debian with Chrome, I'd be like, Wait, how did I install Chrome? Did I install the deb from Google, or did I get it from Flatpak, or did I get it from Snap? And if I got it from Flatpak or Snap, which version did I install? I like the Arch base because I still have the same options, but it's way more updated and way more tied to that release, which is really nice.
Yeah, I mean, speaking of supply chain, something that also used to piss me off a lot on Debian was if you wanted to store something a little bit out there. I think even for Discord, it happens that it says like, "Oh, download my signing key and put it like apt ppa add something," and then you're like, "Wait a second, you're telling me that I just ultimately trust you now for signing stuff?" Or
well, you don't trust them; you trust their key and whoever holds that key. Right, that's the issue.
Right. I think the model in Arch Linux is a little bit more separated. It's not very explicit for users, for example, but there's a separation between core packages, say the Linux kernel, glibc, all of this sort of like very critical things. Not everybody's able to write to those repositories. And then there's the extra, which is like all cool things. And then there's the community repository, which is still maintained by Arch Linux community members. And then there's the community repository, which that's like the division, right? That's the Derby Dragons angle.
And how in Arch Linux, because now Flatpak is talking, FlatHub is talking about potentially commercialization and giving us a reassurance that they don't necessarily say validate the supply chain. They say give packagers security tools, which I think are two different things. So how does Arch ensure that someone's not putting something malicious in a package?
So in the AUR, it's a little bit like anything goes, really.
Wild West.
It's almost like GitHub.
Yeah.
In the repositories, like the maintainer repositories, they're actually there's a lot of due diligence from community members and whatnot. The security team spends a lot of time looking at both vulnerabilities that are not like applied to the packages we maintain, and trying to understand whether they actually translate to the things we're packaging. We spent quite a bit of time trying to reproduce bugs. For example, if somebody says, I don't know, there's a vulnerability on the Linux kernel and I don't know, on the SCSI driver and whatnot, we tried to understand whether that driver is even built, whether it would be loaded by any sort of like rules, and whether we offer it to users on all the lines, right? So we spend a lot of time, and that's part of the fun of being on the security team, which is, can I try to exploit the packages as they're being announced, and then fix them or help the maintainers of that package fix it.
But also, I think Arch has an advantage that being a rolling release, you're constantly pushing out the latest software. And this is a philosophy that I get behind. It's how I try and build my software, right? I build my containers, my environments, always update to the latest version. And I tried to build my Linux systems that way. But like with Ubuntu or Debian, I'm like, you're still using old stuff, and maybe you're backporting a fix, which we can talk about in a moment, why that's probably a bad idea, right? But I feel like security-wise, you're in a better shape with Arch because you're getting the latest versions. And also, I like it as a desktop user, getting the latest features. Like that update to the latest version of GNOME and Mutter and Wayland, I was like, wow. I'm like, you guys made all that work together, which is just, I'm like, I'm glad I didn't have to do that.
It's actually even better as a maintainer, because something that happens in, say, all of these other distros is they find a vulnerability, they can't update to a new version, they need to find a patch and then apply it themselves and then figure out that whether it breaks something. And that's way more finicky, right? It actually puts a lot of burden on the maintainer to make sure they're not shooting themselves in the foot. Yeah,
and did that backported patch, did it actually work is one thing. And you hope they're doing the same level of testing that you said you're doing in the Arch project, right? It's actually seeing if the vulnerability exists. But did they introduce a new vulnerability or a new kind of scenario where a new vulnerability presents itself by backporting that fix and not upgrading all the code that goes along with it to support it.
Yeah, that was a mouthful, but yeah, that's the problem.
That's a huge. Yes, yes. With containers, which is interesting, I'm trying to build containers vulnerable on purpose, which turns out to sometimes be really hard. Well, I shouldn't say build containers vulnerable. Build in a container vulnerable version of software, which means you have to use older software. So one of my hacks is I just use Debian. It's got old stuff in it, and all the older vulnerable stuff compiles against it, which is great. Like I actually use that to my advantage. But it does Arch doesn't have like a container? Does Arch have a container version of itself, and how is that? I haven't used it yet.
Yeah, actually, that's a project that I and a couple of people in the community started, and now it's a very popular container. It's very well maintained. The only issue that it has is if you, for example, use it as a builder on GitHub Actions or something like that, the user land libraries assume that there's a newer kernel, and every now and then it's just missing a system call. Like you start getting a couple of system calls from the host kernel.
Because Arch likes to run on more modern Linux kernels, which is one of the reasons why I like it, actually.
Right.
That's really cool. So my goal is to try and convince more people to get on the Arch bandwagon. I think it doesn't get the respect it deserves.
Yeah, I try to evangelize in my classroom, but it's just a little hard to be unbiased about it. It's really nice.
It's awesome. More questions for Santiago?
Five questions. Oh no, Mandy, go ahead.
First, I want to say on In Toto, love the name. I think it's a really great name. But I have a question separating a little bit from the SBOM information, which is fantastic. But in reading some of your documentation, came across the poly password hasher. And I am very curious on this. Like, first off, in your introduction, there are 2 paragraphs of it that I find absolutely fantastic and fascinating. Maybe you could explain a little bit to the listeners, and then I'm really curious to know, like, how much has it been used or what has happened with it since you started the poly password hasher.
Yeah, so that was another project from my PhD. The fundamental idea is when you're trying to crack passwords on a database, you essentially start hitting the same hash, or you're strategic about it. You're trying to find the weakest password on the database first, right? Back in the day, I don't know if this is still the case, but let me in was almost 1% of the passwords in a database, right? So that was a very good strategy to start like cracking the whole database. The goal of polypassword hasher was to try to link passwords together. Imagine a padlock in that you have 3 dials. In theory, you shouldn't be able to guess one dial individually, right? You need to guess the 3 dials in order to break the padlock. So what we did is we tried to come up with a password hashing mechanism in which you encrypt the whole database, and you can only decrypt the whole database if you know enough correct passwords, say 10 out of the whole database. What this causes is that it creates an exponential cost for hackers to crack the database. For a server, it's actually very, very trivial. When you boot, you wait a couple of seconds, you get a couple of correct passwords from legitimate users, and then you're able to recover the whole decryption key. For password crackers, though, the amount of effort that they need to invest to guess 3 passwords correctly of the whole database, or say 10 passwords correctly, is way, way, way harder. In terms of usage, we collaborated with National Geographic for a little bit. It was one of those collaborations in which we couldn't really tell if it was fully used, but I mean, it depends. As an academic, sometimes you cannot walk into their like data center and go like, is this really there? So yeah, but I would love for it to see a little bit more uptake. I think part of the challenge as well is whether we are going to have passwords for the foreseeable future. I'm starting to see people trying to go, I don't know, WebAuthn and all of these other technologies that it just, I don't know, maybe it's time to let passwords die.
Well, I recommend that people read your white paper on it because it is very interesting. So I feel like there's got to be people out there who would use it, appreciate it, and be able to add to it.
Thank you. We actually have a PAM security module. If you're into that, you can actually just plug it into PAM. If you have a multi-user system, say it actually it encrypts your Etsy shadow, and you're pretty good shape.
Nice. Santiago, I just have 5 questions left for you. Are you ready to play 5 questions with Security Weekly?
Let's go.
3 words to describe yourself.
You got me there? Oh, that's 4. Damn it.
We'll give you a buy on that one.
I could try another one.
Sure. They can all be separate words.
You can hyphenate.
7 words.
You can hyphenate.
Stubborn security person.
All right.
If you were a serial killer, what would be your weapon of choice?
I would like to have something that's like very identifiable. Maybe something like a frozen parrot or something like that.
Frozen parrot?
There you go. That's
So
the first
wow.
time.
it gives you the name, right?
The frozen parrot serial killer. I love it.
Frozen parrot killer.
I love it. If you were to write a book about yourself, what would the title be?
The frozen parrot killer. I'm kidding.
It would be something like a mistakes or something like that.
What is your favorite hacker movie?
I actually can I cheat a little? I think my favorite hacker media was Snow Crash, but I don't think there was a movie about it.
Not yet.
No.
Is there going to be one?
There's
Well,
my understanding
a lot of us,
the options were signed to produce said movie. Yes.
Whether it actually gets made is
Right, that's a different
it's
story.
often disappointing because they say that about a lot of books that we probably collectively love.
Mm-hmm.
They're working on a script and there's been and then you never see it. Hopefully it gets through though.
Yep.
That's awesome.
That reminds me. I need to read that again.
Yes. It's a good reminder.
Yep.
Santiago, choose 2 celebrities to be your parents.
Alive, dead, fictional, or otherwise.
Wow, I'm really bad at this game.
There's no right or wrong answer. Or time limit, really.
And you're really good at it. So
Yeah, you're doing great so far.
You're doing great.
It doesn't have to be a celebrity. It can really be anyone from history, fictional, or not.
Yep. And it all depends on how you define celebrity. I mean, could be a celebrity in your own
to
mind.
you, right?
Right.
Huh. I don't even know. What would be the benefit of? Okay, 2 Smurfs. I don't know.
Which
I
two?
love it. Oh, which two,
Which
though?
2? Which 2?
Yeah.
I mean, it is
Now you're
2023.
driving down
It's 2023, so everything is on the table here, right?
That's right. Doesn't matter. Any
Okay,
two.
two Smurfs. The one that laughs and the one that's angry.
Grumpy and happy. Grumpy and happy.
Sure.
I don't
Get it
know.
out.
I'm
Aren't
rusty.
those dwarfs?
I'm
That's
rusty
not
on my Smurfs. I'm rusty on my Smurfs. No,
Yeah.
wait. Those are the 7 dwarfs.
That's a Smurf
no,
too,
those
Rusty.
Are those are 7 dwarfs, not Smurfs.
No, Rusty's a Smurf.
Rusty's a Smurf?
Yeah, he's red.
Oh, yeah.
He's that dark brown. No, I'm kidding. I don't know.
I only remember, isn't there's Smurfette and Doc, maybe, or is that also a
There's hundreds.
No, there's
of
a
them.
Smurfette.
There's hundreds.
There's definitely
of them.
a Smurfette.
So there could definitely be a happy and an angry. There's definitely an angry Smurf.
I like that we've never debated Smurfs on the show before, Santiago, and you got us doing that. So that was great. Not sure if that was on purpose, but you hacked us.
I don't consider myself a Smurf enthusiast by any means. I don't know why it came to mind. But
It's amazing.
That's awesome.
Santiago, thank you so much for appearing on this edition of Pulse Security Weekly.
thank you. It was my pleasure.
Coming up next, the security news. How to steal a Tesla. Coming up next.